This unit will talk about vision. To understand how the vision works, I have numbered them in steps. The first step involves the light wave passes through the cornea, which is the outer tissue of the eye, and then the light wave will reach through the eye through the pupil. So here's a small tiny opening that regulates the amount of light that enters the eye. So for contracting and dilating, it is charged by the nervous system called parasympathetic nervous system. After passing through the pupil, the light will cross the lens right here and then focus the light wave on the retina, which is the back of the eyeball. The retina, which is the back of the eyeball, is where light is converted into electrical signals. There are two types of photoreceptors there, the cones and the rods. The cones can allow us to see color and fine details under light conditions. But most cones are in the center of the retina. Compared to the rods are distributed across the retina, and the rods are responsible for our night vision. Rods and cones are responsible for us to adapt to changes in light conditions. So what happens to your vision when you went from bright outside to a very dark room like the cinema? So you can't really see anything clearly for a few minutes, as rods takes longer to adapt and are more sensitive to light. But when we change the situation, when you go from dark inside to bright outside, it's quicker because light adaptation is faster, because cones are much faster to respond. As noted earlier, cones are in charge of color vision and fine details. For the scope of this course, we will cover two major theories on color. The first one is opponent process theory, and the other being the trichromatic theory. Based on the opponent process theory, our cones respond to pairs of colors, so white and black, green and red, and then yellow and blue. So some cells are excited by one of the opponent colors and the other will be inhibited. So this slide just summarizes what I've just mentioned. So this explains why we don't see greenish reds or yellowish blues. So this is the trichromatic theory. Based on the theory, normal-sighted people will have three types of cones: the S cone, the M cone, and the L cones. For the S cone, it responds best to short wavelengths of light, so we can see the color blue. And for M cones, it responds best to medium wavelengths like green. And for the L cone, it can respond best to long wavelengths like red. So you might wonder, if we only have three types of cones, how are we able to see so many colors? So the answer to that question is that different wavelengths can actually be combined to see different colors. Color deficiency or color blindness is typically a genetic disorder where people's one or more of the cones are absent. However, other types may develop due to injuries, eye diseases, or other health problems. In real life, there are a few women who actually have 4 different sets of cones in their eyes, and some research suggests that their experience of colors may be richer than normal people. After covering the biological features of the eye, let's move back to the brain, which is the control center for vision. So the electrical signals in the retina will move to the optic nerve and then to the thalamus, which is a place where important relaying information will occur, and is a gateway to the cortex. And finally, they will send the information to the primary visual cortex. The primary visual cortex is located in the occipital lobe, and the information about light orientation and movement will be linked together there. The information will be sent to other specialized cortical regions, like the falciform face area will specialize in processing faces, and damage will result in different agnosia, for example, the inability to recognize faces. This is a closer look at the specialized regions. The ventral pathway is the what pathway, so in charge of recognizing things. The dorsal pathway is the where pathway, which is important in localizing things. In this video, you may see a patient with optic ataxia. So this is having difficulty to use their vision to guide the reaching and grasping movements. So she has a damaged dorsal pathway, so don't know where things are, but her ventral pathway is intact, so she can identify objects. In the next video, we will talk about hearing, which is audition.